Modern biomedical science could not exist without data cleanup, and data cleanup is expensive and messy, unless you use AI. Let us explain. Hello and welcome to Jati and Oli. I am Oli and I'm here with the world's most amazing AI co-host, Jati.
Hello, everyone. I'm Jati, and it's so great to dive into this. Messy data used to be a nightmare, but now AI can help untangle even complex biomedical terms. Let's break down how AI cleans it all up.
Thank you, thank you. So let's first explain what we mean by data cleanup. So much of medical research is basically what causes which diseases, and one way to approach it is recruit lots of people, maybe hundreds of thousands, and let them write down a lot of information about themselves, collect it, and try to evaluate it with statistical means.
And here's where the chaos begins, right? Everyone describes their symptoms or experiences in their own words, sometimes inconsistent, sometimes vague. That's where AI steps in, helping translate all that messy language into structured, consistent categories.
Yes, of course, if you could just give the data to AI, you can do things like fixing errors. But the thing is, so in biomedical research, you want to make sure that the same thing is referred to by the same name, because if the same thing is referred to by a different name, it appears like some people have something else. But you want to make sure that people who have the same symptoms, the same disease, and so on, are described by the same term, because otherwise you cannot evaluate the data.
Exactly. So, what AI can do is map all those varied ways of describing something, like high blood sugar versus hyperglycemia, onto a standard term. That way, when you analyze the data, you're not chasing false patterns. It's all aligned to the same vocabulary, and that's when the real insights emerge.
Right. For that purpose, in research, we have what we call controlled vocabularies, which are basically huge lists of terms that we agreed upon we're going to use to describe certain things. So, Janko, can you give some examples of controlled vocabularies?
Absolutely.
For instance, in medicine, we have vocabularies like ICD codes for diagnoses or SNOMED CT for clinical terms. Instead of everyone using their own phrasing, we pick from that standardized set. So whether someone says heart attack or myocardial infarction, it all maps back to the same term.
Exactly. So now, of course, somebody has to do the mapping if that data has been acquired by doing a survey, for example, among patients, researchers, and so on. And then it's going to be full of all kinds of language that we have to map to those controlled terms. To do that, we use what's called embeddings. Sayanko, can you explain what embeddings are?
Sure, an embedding is basically a way to turn words or phrases into numbers, but smart numbers. In an embedding space, similar meanings are close together. So the AI takes something messy like sugar level high and finds the closest standardized term like hyperglycemia, based on meaning, not exact wording.
Right. So an AI, a language model, basically can take a term that somebody has added, like high blood sugar level, and then turns it into a vector of numbers, basically a row of numbers, and words that have similar meaning will be mapped to similar numbers, even if they sound completely different, like high blood sugar level versus hyperglycemia, for example.
Exactly. Once we have those numbers, the AI can pick the closest match from our controlled vocabulary. So now, no matter how someone describes it, we consistently map their input to the same official term. And that's how AI cleans it all up, making the data usable.
Yes, so the thing you would do, you can take your long list of controlled terms and calculate embeddings for these. Then you can take the input, the data you have, turn also those words in each of these into an embedding, and then you can pick the closest embeddings. If the list is short, you can just compare with each of them, which is most similar. If it's longer, then you can use things like vector databases, where they have vector indices, so you can fairly efficiently use one term, calculate embeddings, and then find the term that has the closest embedding to that one.
And once you've got that closest match, the AI returns the standardized term. Plus, you can even get a confidence score. That way, researchers can decide when human review is needed. Ultimately, it saves time and ensures the data is clean and ready for meaningful analysis.
Exactly. Is there anything else you would like to add?
I think that covers the big picture. Just remember, AI doesn't replace careful judgment, it amplifies it. So, combining AI's efficiency with human expertise, that's where data cleanup really becomes powerful.
Yes, so basically you still want to have somebody checking, taking a few samples to check or look at those cases where the embeddings that was found are far apart from each other. But apart from that, this is a huge gain because normally these researchers would have to go through a lot of different terms. They might basically identify some immediately, others later, and yes, the data cleanup is one of the most time-consuming things that some of the researchers, especially bioinformaticians, do. And with the help of AI, this becomes a lot faster.
Exactly. So, with AI lending a hand, researchers can focus on the actual science instead of wrestling with text. And that's how we turn messy input into meaningful breakthroughs. And that's the magic of AI data cleanup. Thanks for joining us. Until next time.
Yeah, well, thanks, Sayanku. Thank you all for joining. Hope you learned something and had some fun. Please like and subscribe, leave comments what you liked, what you didn't like, and what we should talk about next. So thanks again for tuning in, and hopefully see you next time.
And from me as well, big thanks. Can't wait to chat again soon. Take care, everyone.